Start recording. Okay, so what we were talking about was we just flipped our coordinate system, cleaned up a bunch of to-dos, did the winding order stuff, and we were talking about how we should probably just finish off the to-dos and talk about how Stackalloc works. So we have this one here down in do separation. Get rid of this allocation. So the way I think we'll run it today, because we haven't done this for a while, and I know you're super keen for this, and that is I'm going to start you off with this equals stack alloc vector 2 question mark question mark question mark and then I'm going to have you take it from there, and we'll see where we go. And if you, I like Stackalloc with an H. It sounds demonic. So
okay.
I'm going to hand it over to you, and we'll see where we go. And I mean, if you have any questions or anything.
Yeah. Okay. Sure. I mean, I'm just surprised. I mean, I'm not really surprised because I've seen this before, but I wasn't expecting this to highlight. So I think we spent some time talking about, I mean, off air about how Stackalloc isn't really available. But for one, I'm just gonna follow the for list. Oh, I forgot the pointer. Okay, so immediately I gotta go to unsafe context because I'm doing pointer stuff. So project properties, wait forever, because
Yes.
Studio was designed in a way that probably is not using Stackalloc.
Yeah, I think it's under build, and don't forget to change these suckers to all projects. Oh my god, I can't believe how slow that is. You can see you can see it redrawing, like you're playing King's Quest or one of those old, PC adventure games.
This is a 2017 laptop,
Holy
32
shit!
RAM, NVMe Pro Samsung drives. Nothing on earth should be stopping this thing from rendering. This is all VS.
Wow.
Okay. So
I will say I had a whinge on Twitter about Visual Studio being slow. It took 5 minutes. Just holy cow, that's slow. It took 5 minutes to start, and they're like, update it, and I'm like, all right, I'll update it, and then it was still slow, but not egregiously slow. So,
well,
that might be worth trying. So
yeah,
okay.
well, I think I'm already at the latest version. I've kind of update pretty much immediately. This is still telling me that this can. Oh, that's because I'm probably.
Yeah, sorry. You said unsafe context, and I'm like, unsafe. Oh, we're done. But yes. Okay, so you got that one.
Yeah. Okay, so I got the build. I got that unsafe. I need the size of some kind. This is interesting. So I've never done this inline like this before. But I suppose. Well, what was the count before? Did we even have a count? We didn't. We didn't care. I have to care now.
So we do need to care now.
So I think. Well, I mean, the maximum size this would probably be Well, I have no idea. How many? I mean, right now we're dealing with triangles, and I think we're it's probably 4 right now, just because we only have that many.
This is true, but
possible vertices.
But well, we're only dealing with triangles now. But to start with, there's going to be more than 4. But also, I will come in there and be like, all right, let's add a vertex and watch it crash.
2, 3, 4, 5, 6, 7. It's an 8 for a rectangle? 8 vertices?
It would be 8 for a rectangle, but I'm not going to let you just stick a fixed number in there because it will crash.
Okay, well, I don't know why yet, so I'm going to think about that
we'll stick a fixed number in there, and we'll add a to-do. That's fair enough. So, to-do
Help me. I'm not well versed in
That's all right.
real
So
programming.
what have we
So
got?
I'll
We've got
just
circle axis.
I gotta fix these. I gotta fix all of these. Unsave this. To be fair, it might be ReSharper that's causing a lot of the performance issues because that seems to be getting worse now. Oh, I mean, okay, it's a political statement, but it seems like it's getting worse now, even that since they came out with their own IDE.
Oh, really?
Yeah. But I couldn't say for sure. Maybe I think it's kind of just gotten worse a little bit every day since, like, just in general. Okay, so what to do? So I don't get any of these fancy ads anymore.
Well, first of all, let's fix a little bit of a bug here, and that is this one and this one. I have no idea what that's still doing there.
Huh. Wait a minute. Which one shouldn't be there? It's this one, right?
Both of them, in fact, they're both from when we had fixed axis rectangles.
Do you have them in your code or not at all?
No,
Oh, you don't. No.
I don't.
I don't.
So they must just be left over somehow.
Mine still worked. So what are those would have done? What of those would have drawn and
well, as we talked about with the algorithm, you know, there's we're doing separating axes. So if we have like two triangles, and you know we're gonna test them on like this axis here, that's like 90 degrees to that and 90 degrees to that, and you know this axis here that roughly speaking is 90 degrees to that and like 90 degrees to that, and this axis here which is like 90 degrees 90 degrees. If we chuck another axis in that's like you know 90 degrees and 90 degrees, this extra axis is not going to have any effect, but it's also not going to break the algorithm. It's still, you know, you can test separation on that axis. It'll never be the minimum separating axis, I think. Pretty sure. It shouldn't be the minimum ever, and yeah, it'll just you know either.
In our yeah. I was gonna say in our the algorithm where you're like using wouldn't optimize for that, so it would at least slow it down.
Oh yeah,
some small.
Yeah, it's just an extra axis to test, so just wasted calculations basically.
Okay. Okay, so if okay, so now I have to be deliberate about the success here.
Now,
dealing with a fixed size buffer, am I not, or am I? Well, I'm not sure yet. I'm just.
So I'd be very careful with that either.
Oh yeah, poop. Yeah. Okay, so I need to know the index I'm on. My array. Do I need to add to? I need to. Do I need to pass like a ref to the index to this?
I'm thinking that's probably a smart plan here, because basically we're replacing list with a array, a pointer to an array, and so if we think about what is list, you know, it's an array of a fixed size and a count, and the count increases as you unfortunately we can't navigate to it as such, but yeah, so so what you've just written is pretty reasonable.
Okay, and then right, so I know this is gonna crash, but I don't know why yet, so I'll leave that still. I mean, I have many questions. Like, you're saying we're not allocating, but we are allocating on the stack.
Yes.
Just not heap memory, I guess.
Exactly.
But I guess, but yeah, right, because the list is not a value type. Interesting. What do I get for this guy? Probably nothing. Okay, fair enough. Nothing it is. Um.
Um,
Oh,
well, this index value you have here, um, at this point in the code, it's kind of a misnomer. Uh, it would
it's more like a count.
exactly. So this count is probably a better name for it.
That means I can just use this.
Hmm. And so this is very similar. Like, I think, do we have something like this already in this code? Yes, we have something very similar. So we have this shapes and shape count and this pending separation. So it's actually very similar to this, except these are arrays and this is a pointer. So it's pretty similar.
Okay, well, okay. So I did the rudimentary stuff. So there's no more red splats. But tell me about how I shouldn't be doing. Is this just because this should be like a primitive?
Well, I mean,
I could run it and just find out what happens, I guess.
You're just guessing the maximum number of axes that you're going to have. So let's draw a thing. I mean, we could say, I mean, we kind of could do what you've done there, and I don't think what you've written there is going to crash. So if we have triangles like I don't know, suddenly we have 1, 2, 3, 4, 5, 6 axes. And if we have like a square and a circle, we have 1, 2, 3, 4, 5, 6, 7, 8 axes.
Yeah, I was thinking, I was stupidly just considering what the shapes themselves. I wasn't thinking about the actual, like, we're not doing that. We're creating a list. We're creating a buffer of axes to test, which has got nothing to do with that. So yeah, it has to be kind of like worst case scenario of however many versus however many. So
exactly,
polygon versus polygon.
So you can imagine if we have like a shape like that, roughly, and a circle, suddenly we've got 10 axes and so on. So I mean, we could, like, in theory, it's not unreasonable to do that, for example, and just oh look, you ran it and you found the bug.
I overran the buffer.
You overran that buffer. So yeah, it's not unreasonable to just say this is the maximum number of axes. So we could stick that maximum in either direction. So
right now, do you const that normally, or do you just pass that in?
No. Okay. Like, so this is okay. So this is a value that we have. We have to do something with some kind of maximum here, and we have to do something with that same maximum over here, where we're adding the shape. And so the question is, where are we going to enforce that maximum? Are we going to allow an unlimited number of vertices and then have to recalculate this maximum? Or are we going to have a fixed maximum and limit the number of vertices? So we could go either way. Which way would you like to go?
Well, just thinking of the games that I would make with this library, it probably makes a lot of sense to limit the shape vertices.
Okay, that's good. Okay, in fact, that makes life kind of easy, really. So, excuse me. So if we go and let's make a constant up near the shapes and be like const int max shape vertices equals, I don't know, 20.
Yeah.
I don't think, like,
maybe make more than one shape then if you're gonna make a compound.
Exactly. And libraries do this all the time, and that's pretty reasonable. So by specifying this, we've basically said that the number of vertices we can add here is no more than 20. So probably the first thing...
We don't really need to... Oh, sorry, go ahead.
Oh, I was just going to say, we probably don't need... Like, this is fixed at the moment. If we ever add a thing that can do an arbitrary number of vertices, we'll probably want to deal with it. But for the time being, we've added an assumption to the code. So this is where we reach for debug.
Yep.
Assert. Can I have debug, please? Shapes.
Oh. Well, we've already incremented the shape count.
Yeah. Over here is the increment.
Yeah.
And so just keep in mind this null check, because this is actually a valid form of this thing too if we're just putting a circle down. So yeah, so that makes life easy. I'm going to disagree with that piece of code.
Sorry, hold on.
That's all right.
It's almost always the case, isn't it? Hold on. This one's okay. So this is you're saying it's either. I was saying it's either. Oh no, it's either null.
There you go.
We don't. Yeah, we don't care or we do care. Okay.
So so now we have that. We can drop back down to here and be like, all right. And this is in fact. This is probably the easier way to do it. Like I would have been inclined to actually go and calculate this on the fly, but then you have to like track. It's like, how many vertices exactly do you have? What's the maximum? Whereas this way, we can just be like,
but doesn't it take? Does that take? Isn't that take quite a lot of operations to like scan all your shapes and look for the max? Or are you going to do it? Are you going to update it in the update loop? Like
I would have
track a variable.
I would have tracked it when adding a shape. I would be like, all right, give me. If I just added a shape, it would be like, vertices dot count. Max vertices equals max vertices dot count. And then we'll just keep track of the maximum. And then it starts to get really ugly if you have to start allowing removal of shapes. At which point, perhaps you just not bother changing the maximum and just
expand only.
But that's the thing that you can do. But now we have an actual value here, so we can just be like, all right, it's the maximum, and hopefully that, like we were saying over here, if we have a polygon with 4 sides and a circle, we have double the number of vertices, essentially. Double the number of axes. So
what about polygon versus polygon?
Well, polygon versus polygon would be, again, that would be, say the maximum was 4, for example. Then, we'd have polygon and polygon. So we'd have, again, double 1, 2, 3, 4, 5, 6, 7, 8. So it's double again. In that case.
Yeah, but if it's a 20-sided polygon versus a 20-sided polygon.
Well, in that case, it would be
it's double
that time as well. So yeah, so what we want is exactly what you have written there. So max shape vertices times 2. Okay, and then we're done. We don't think we need to do help there anymore.
Okay. We didn't do this at all almost ever in River City. Not to, maybe we didn't need to. I know that we replaced quite a few dictionaries with lists because of because removing all the extra storage and the need for an indexer, because most of our indexes were natural. But in this case, why didn't we?
We actually did. Although, interestingly enough, if I search the actual code base, I find a whole lot more instances than these. So there's probably some outside of Pixel 3D. But so let's see. We've only got 3 files here, so let's take a look at how we use it. In fact, I don't think we use it in the Vorbis decoder either. So okay, so consider modifying. Okay, so yeah, this is the thing where we like allocate some memory I don't know where, somewhere, maybe here. And it's like, oh, that could be Stackalloc or VF. Oh, okay, no, so okay, so this is this is Ethan's Vorbis file binding, and it's like ov open callbacks from memory does a native malloc in the native code to get some memory that it gives us back that we use for that. It's like, well, we don't have to malloc that. We could just stick that on the stack. So that's okay. Wasted allocation. But obviously, like when you're decoding Vorbis stuff, and it was like, down here we OV clear, that's going to free up. It's going to immediately free that memory. So it's not even such a big deal. It will probably be quite fast, and so not really a huge deal. And it's just on the decode side. It's not like we're in the middle of a frame. This one, what's this? This is the run length encoding reader for that. Okay, so there's a palette. .NET is probably going to do a memory clear on me. Okay, this is the interesting thing. So where's the other one? Where is it? Stackalloc.
Minkowski.
Here we go. Okay, so the C# spec on stack allocation, the content of the newly allocated memory is undefined. So there's no guarantee that this is going to be zeroed. And in this particular case, we need it to be zero because we're using it like a set of flags that we're filling. So we want to zero that memory, which we use memset for because we want that to be fast. Whereas over here, it's like, oh, we're going to allocate a palette, and rather than allocating just a max size palette, just like we were doing over here, rather than just being like, oh, I'm just going to say 1,000 and then whatever, or in fact, like we're doing here, it's like 20 times. This is 40 axes. It's like we're never going to hit that in practice, so we're kind of wasting a little bit of time by clearing it, because even though the specification says there's no guarantee that it will get cleared, the runtime will actually clear it for you. So that's just one of those things where it's a bit annoying. It's like, you didn't have to clear that for me.
Right.
But but we have to put this in because that's what the spec says. So someone could run this on a compliant runtime and not get this clear, and suddenly all of the physics breaks. Yeah. So this is basically this is basically we need a block of memory. I mean, there's not really that much to say about these two instances. We need some memory to store the palette as we read it out, that we then decode the compressed image into. And in this one, we need a huge block of memory, or huge-ish block of memory, that we're going to basically do the Minkowski fill situation on to find places in the level we can do fitting of shapes so that we can separate them. So if something gets stuck in a wall, for example, we know where it can get popped out to. So those are the two places, at least in Pixel 3D, but I think there's another 3 or 4 places in the
engine proper. Okay.
But yeah, so we don't use it too much.
Yeah, it's not like conventionally replacing any use of a list, for example.
Yeah, I certainly, where possible, I prefer to, actually there's a whole bunch of AI stuff that uses it too. So that's what's missing from
yeah, that's not in yet. It will be soon. Not yet.
The AI has to allocate a array that represents the ground around it and sort of fill that section. And I prefer to do things if I can do it with a Stackalloc, that's much better than doing it with either what we were doing before, which is just allocate on the heap and hope it gets freed. That's going to put a lot of pressure on the garbage collector. Or have and we could have done this. We could have done list vector 2 axis temp equals new that, and just reuse that, or we could like make a pool or something. But
right, and that's going to cause, that's good. Now we're talking about thread safety too.
Yeah, and so
I guess not in this, maybe not in this game because we're kind of on a game loop and it's probably pretty safe. But
well, no, not well, sort of. I don't think we ever actually did this, but we certainly could have.
Simulate in advance in the buffers in the background.
Exactly. So obviously, obviously the game itself, when it's just running normally, it's just running single-threaded and it does its thing. But when it has to go back and re-simulate for the network, it could, in theory, do that on another thread, and it was always set up that way to do that, just in case we needed the extra performance. Because everyone's got multi-core now, so it's like if we did it that way, it's like suddenly we can do it almost for free, because otherwise that core is just sitting there doing nothing.
That's right.
And then once you have that situation, if you've got that thing here that's like axis temp, it's like, well, you need either need a whole lot of these per execution unit thing, which gets tricky code wise, or you need some kind of thread safe pool that's managing them, and then you have to have you're having to have locking between threads, which is not something you really want when you can get away with it. When you can get away with not having it. Yeah.
Just for clarity, when you said having to pin them to execution units, you're referring to like the thread local storage type of concept?
Well, I'm thinking like, okay, so if you have say you have do separation, it's like where is this storage? If you can imagine that you might have like multiple instances of physics game, aside from the fact that ignore the fact that it sets up a graphics device and stuff. But if you have multiple instances of this class, then you have multiple instances of the list, wherever that went. And so if you have like one of these classes instances per thread, then this is actually not too bad. Whereas if you had that for some reason, this is going to cause you a whole world of hurt, because suddenly you're going to need to actually lock on that. And like if you have this situation and you go to thread it, or even just if you go to thread it, suddenly you kind of want to replace that with a thread safe pool or something. Whereas this, which is it's like each thread has each thread has a stack, so we just stick it on the stack. So yes, that's all that. Any other questions?
No, that's pretty useful. I mean, it'd be interesting to measure the difference. But
well, in this case, at the moment, it's probably hardly any difference at all, because I don't think we're putting much pressure on the garbage collector. But as we know, if you're making a game using C#, it's like you want to minimize how much you touch the garbage collector at all, because you might get into a situation where it's like, oh, this particular system needs dynamically allocated memory for whatever reason. It's like the amount you can minimize that, the amount of pressure you can take off the garbage collector, the better. And also it allows you to have a bit more control about mixing, short-lived objects with long-lived objects, which, is another cause of slowness. I think we talked about that last time.
That's right. Yeah, we touched on it. I mean, this is a deep topic, but
yeah. So let's run this and see if we break anything. It should. That was interesting. I think we might have broken something.
I'm still building, so.
I was like, I made a whole bunch of shapes and I hit space, and the damn thing just flat out crashes, face plants.
It says nope, no more game.
Which is really, really interesting, because I'm like, did yours do this? You actually get the crash. I probably have exceptions turned off, and it's just
noping out of there.
I
Whoa,
think.
my index is insane. I did something wrong here.
Ah, I know.
I didn't
Ah,
reset the right spot.
so
Yeah,
you
hold on.
recall that originally the code looked like this: list vector
Yeah,
two.
and
Uh,
I stupidly put this all the way up here so that it would increment like throughout the entire
mm.
operation, which is just
In
not.
fact, the whole thing probably can move down here.
Yep, that's
Can
exactly
it?
what I'm gonna
Does
do.
that make sense? I think that makes sense. Yeah, that makes
Yeah,
sense. So
yeah,
that's
yeah. No, yeah, I just derped it. I
yeah,
just
no,
clanked it.
that's a totally reasonable thing to do. I mean, I made the same mistake. I didn't notice it until it crashed. This is the peril of Stackalloc is like you're gonna get weird ass crashes if you make a mistake.
And that's why it makes you say unsafe, right? I mean, unsafe isn't for the developer to say like it's not unsafe programming. It's simply you got to know what
It's
you're doing.
you're making like a promise to the compiler. It's like, yeah, I know what I'm doing. It's like, oh, you hope so. Um, is that have I got to sort this out? Like you can see here, like I've got assert there, and I think I've got a bunch more asserts. Like, uh, I'm checking the size, but I had some pretty bad um, memory stomping bugs from using Stackalloc, and I think one of the reasons is when you're programming a whole lot in C Sharp, obviously you have memory safety, and you don't get that practice at like not clobbering memory. So that's another thing about Stackalloc is like you're not used to the things that can go wrong. Whereas when
Right.
you're doing a whole lot of native programming, it makes life a little bit, I guess, not easier, but you get practiced at that fairly quickly.
This is kind of like Katamari Damacy. There's always a bigger circle to eat the other
Yeah,
circles.
I'm liking that. um,
There's a game in this. I just don't know where it is yet.
mm, mm.
Maybe it's like you have to pick the right shape and the right size in order for almost like curling in order for something to get knocked out in a certain way so that you can score it and then it keeps getting smaller, something like that. I'm
Ah,
sure somebody clever could come up with a real game with that.
that's interesting. That's. All right. Well, we'll keep that one in mind. Let's.
So I think,
Sorry.
oh no, sorry, no, it's fine. I was just saying it's sort of like Conway's game of life, but like with the concept of things keep getting like how like atoms are constantly growing, so everything actually starts getting smaller and smaller,
Hmm.
and then it'll speed up, and then eventually you're like throwing down shapes like in an alarming rate or something like that.
Mm-hmm.
Anyway, we can do a
And
game design thing some other time, I
it's like
guess.
that's interesting. Um, so we've got like I don't know, 15 minutes or so. So let's bang out this other thing that I think this is the last to do. So can I search the document, please?
Searching for to-dos. That never happened. Oh, I don't need this anymore.
We've got two of them. Can we
Yeah,
algebraically?
algebraically optimize get mass.
Well, let's do the easy one because this one's super simple.
Sure.
And it's like, all right, what about the radius? Could we set it? And the answer to that question is yes, we could set it.
Why would we do that?
And the reason why we do that is okay. So um, let's get this thing going. So say we have all of these shapes that I've just drawn here, and it's like maybe some of them even collide, like that, for example.
Oh, yeah.
Now, what we're doing if we have 1, 2, 3, 4, 5, 6, 7, 8, 9 shapes, we are testing, this combination and this combination and this combination and this one, this one, this one, and you can imagine, whatever 9 times 9 is, we're doing 81 tests for 9 shapes, and then if we have 10 shapes, we're doing 100 tests, and if we have 100 shapes, we're doing what is it? That's 10,000 tests.
Yeah, well, I
Yes.
mean, the buffer overrun we just saw, my index was like well into the like 10 million or something. So,
Well, there you go. Um,
yeah.
so, what we would like to do, we can't avoid, well, we can avoid it if we do like some kind of spatial partitioning. So you can imagine we like chop the
Mm.
space in half and like, well, we won't let things cross between these two halves unless they're actually like straddling that line. Like you can imagine that maybe those shapes will get tested on both sides, but we could divide up the space. So that's how we break down that that O n squared thing. But we can just make this faster, and we touched on this the other day briefly. And one of the things that's going to be a pain in the neck about this O n squared thing, particularly because it's like we have 9 shapes and they're the only ones that overlap. If we can reduce the amount of memory that we're touching in this thing, that would be a good start to making it faster. Like all of these ON things, really they're O K N squared. And if we can make K really small, then we can mitigate some of the effects of this thing. We can't completely get rid of it, but the amount of headroom I guess we have gets a lot larger. So one of the ways we can do that is we can say, if we track the radius of these shapes, it's like, all right, well, this radius and this radius, here's a circle, here's a bounding circle, and all of a sudden it's like the only 2 circles that are touching is this one. So we don't even have to load the vertices for this because we're storing the vertices off in another array, and so we don't even have to load the vertices, which is going to make this a whole lot faster, and we don't even have to consider them. We can just do a single calculation to find out that, of all of the 81 possible intersections, this is the only one we actually have to really do anything substantial to. So let's start. So we need to know the radius of these shapes, and so we have position vertices. This is actually fairly simple. So shape count dot radius equals, and so it's going to start at 0. It's like 4 shape count, and all we need to do is get the radius of the we have to get the distance from the center of the shape to the vertex to get the radius. And this is not exactly perfect. You can imagine if we have a shape like this, and the center is off over here for some reason, we're going to get a radius that looks like this. But
Right.
for most sane shapes that have the vertex about in the center, like even these triangles, the way we've done the triangles, the center of it is going to be here because we've just chopped a square in half basically. But even then, that's going to be a reasonable approximation, even though you can imagine maybe a better approximation if it was I'm not sure it really applies in that case. But
sure, but I mean, you're just talking about this as like a fairly cheap heuristic we're using to cut calcs.
Exactly. So all we have to do is say shape count vertices I dot, and then we just need the length. And we're doing a square root here, so we're trading a little bit of setup time for this, but seeing as the setup happens once, and do separation in a real simulation probably happens every single frame, even though it's not doing any work, we still need to check it doesn't have to do any work. So this is definitely a win. And then we just be like, if I is greater than
of array access plumbing here.
Yeah.
I probably would have done. I probably would have inlined at some point, way
So
sooner than you.
so you can see this is where it becomes. So you know how I was saying it's like, yeah, the thing that you do is actually really nice, which is like shape equals shape. My keyboard is like half an inch to the left. Shape count. Here we go. Okay. So normally you do this, but this obviously doesn't work because
you have to assign it back into the array.
Yeah, instead of writing to the thing, you're writing to.
But aren't you implicitly kind of like But aren't you accessing it 4 times? Like, I mean, this is probably elided by the compiler, so
yeah,
it probably doesn't matter. But I'm just...
this is the fast version, basically. This access here is cheap as free, basically. You don't have to the CPU doesn't have to do any extra work to access an array element by index. Whereas if you're like copying a thing out of the array and then copying it back into the array, unless the compiler actually is smart enough to elide that, and I don't think it is.
We'd have to crack open MSIL. I'm curious about that, but yeah.
Well, we'd have to actually crack open the JIT output. We'd have to open the disassembler, and we could do that. I'm trying to remember how to do that off the top of my head. We could give it a look.
ILDASM?
No, I mean we could use ILSpy or ILDisam. Disasm. I've never had to pronounce that, but yeah.
Yeah, it sounds kind of rude when I pronounce it. ILDASM. A little bit.
We could crack that open, but no, we actually need the disassembly. So I mean,
we don't have to do that today. Don't worry about it.
Well, we've got a few minutes, and let's have a quick gander, let's say. But let's just check this works. So we've got the radius. We're setting the radius. Maybe let's finish this off, and then if we have some time, we'll have a look. If we don't,
because the thing is, this is this is an array, so this is a reference type. This shapes bag.
Yes.
So I really don't see. So I guess. So no, but shape is a struct. I still have to.
Exactly. So if shape was a class, then you'd be right, and that would probably be a sane way to do it because it's a struct. This is why I'm used to doing it this way. Now that I think about it, it's like I just do it this way.
The only other thing too is I don't think you need the radius is 0 at the top because it's going to be assumed to 0 because it's uninitialized.
Oh yeah, it's
But
it would be initialized. It'll be initialized here. We don't need that. So we don't actually need that. But
that's fair.
I'll leave it in just because it's explicit that we're starting with a radius of 0. But yeah, you're quite right. Like this line of code does nothing, or certainly it does the same thing as this. And in theory, this is something the compiler will elide. Hopefully, the JIT should remove it. I think. But yeah, for the sake of like clarity of the code, that's probably why I would leave that one in there.
All right.
Let's roll down to do separation. So we have shape A, shape B, and we're copying them in here. And whether this ends up as a copy or not, I don't know. We'd have to look. So maybe that's something we can do when I always forget how to bring up the disassembly of JITted code, and I have to go and look it up. So it's a 50-50 chance I remember off the top of the head. So we've got two things here. We've got shape A, shape B, and they both have radiuses. And so the question is going to be, do they intersect? And okay, so what we want is float distance equals A, actually distance squared, shape A dot position minus shape B dot position. Actually, let's use vector2 dot distance squared, rather than doing the subtraction ourselves, just for fun. And then, so we have this distance squared, and then we have two radiuses. And so basically the question becomes,
why did you use position instead of radius?
Because we need to use both. So basically we have two lines. We have the line between, say, here and here.
Yeah.
And then we're asking, is that line longer or shorter than the line between here, here, plus here, here?
Oh, yeah. Okay, so this is the red line. We have to get the red line first.
Exactly. So you can imagine in this case, it's really hard to see, but you can imagine they overlap here, but this one's like comes through the middle. And so you can see that the addition of the two blue ones is going to be longer in that case, whereas it's shorter in the case of the
and therefore we keep it in the loop. Otherwise, we would boot it out. Like we would continue.
Yes, exactly. So, okay. What we need here, if distance squared is now I've completely lost my train of thought. If distance squared is greater than the addition of the two things. Okay, so shape A. It's greater than.
So I wasn't gonna square them, but I should. It makes total sense though because it's distance squared.
Mm-hmm.
You can't just sum two things. It has to be the square of the.
Exactly. So this is a handy little pattern. Like this sort of thing comes up a lot. Comparing distance squared, because obviously if we go into here, this one we can have 12 and we've got distance squared. Whereas if just regular distance is the same thing, but we've got this nasty square root there, so it's like, well, we don't need the exact distance, so we can get rid of that awful square root and square this one instead. So that's just simple algebra, square both sides. So let's see if that worked, because that's obviously that was really simple to code. That did not take very long at all.
See, I'm still building.
Although,
you got like Windows 7 on there, right?
Although, is that a bug? That's spookily like a bug. Did you see what happened there?
No, I was mesmerized by my lack of speed.
I did see that. I'm like, golly. Like, so you were saying your computer's like
top of the line
2017 laptop.
Yeah.
This is a desktop, and it was pretty good when it was new, but it was new like 7 years ago or something.
Yeah. No, I've got a GTX 1070 Max Q GPU in this thing, and 32 gigs of DDR4 and la 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 la. Like, it's a decent laptop. I don't understand. I think it must be resharper. I might try running without that for a while and compare. So, what was the bug? Sorry, I missed that. What, we have a bug?
I have a suspicion that we have a bug because if I make a big shape here and a big shape here, and it doesn't happen every time. Like, see, that was fine. That was fine. That the whole assemblage
Everybody moved.
Yeah, that's not supposed to happen. So there's a bug in here somewhere. So I think we'll close out the stream because we've hit the hour. But there's something that's going to be fun to figure out what's wrong with that. And
Well,
I'll
that'd be a
try it.
good exercise in like trying to figure out how you even break down that kind of problem. How are you going to find it? Are you going to add more visualization to it?
Yeah, yeah, that's an interesting one. So, all right, let's you know how we deleted all that Viz code earlier? We'll bring that
Yeah.
back perhaps. All right,
Okay.
so let's close out the stream. We did the radius thing. The only other to do was that
Oh,
this, but we'll
algebraic.
we'll we'll leave that for
Okay.
later because I
Well,
mean no one really cares.
I had two though. I have two to dos. You only
Oh,
have the
what's your other
one.
one?
Mine was the uh, cache line optimization for vertices.
Oh, did we
Is
actually
that
have? I don't think we have a thing for that. And this is possibly I mentioned that when we were talking about the radius thing, and that is now that we're not even bringing the vertices into memory if we don't actually have to do a full collision detection between say it and another shape, we don't care so much about whether the vertices are going to be sitting in cache in a sort of reasonable order because we're not even accessing them linearly one after the other, and we weren't in the first place because it was O(n) squared. So now we are doing like a random memory accesses, and like the individual vertices, they are cache aligned or cache not
yeah, that
aligned,
makes
cache
sense.
coherent for per shape, but between shapes,
Right, but
nothing we
yeah,
can
but
do.
what you're saying is like we're not looking at these shapes contiguously. Like you said, it's basically random. So therefore, there's really nothing you can do for the cache line.
Exactly, and but that's fine because like much better to not access them at all than like worry about accessing them quickly. So that's
Right.
fine.
We've gone from every shape possible to basically just the shapes that are loosely probably maybe could be overlapping.
Yeah.
So
So I mean,
that's a huge win.
if we scroll up here, like we have this shapes array, which is going to have all of our shapes in it, and we've got this struct. And so if we wanted to start thinking about optimizing it, we have 16 bytes, 4 bytes, 4 bytes in a 32-bit build. So we could do something like pull that out because we don't necessarily need it. We could structure arrays this,
Hmm.
but
Could
you can
get rid
see.
of pending. Could we get rid of pending separation too? Because aren't we gonna deal with that on each tick? Pending
Uh,
separation.
no, because pending separation is where we accumulate separation. So this is the issue that we deal with when we have like a whole lot of things overlapping at once. They separate, but then they separate into each other because some of them are like, oh, we definitely have a bug. That's so if I
Whoopsie.
stick a shape in the middle and hopefully don't trigger the bug. Oh, yep, we've got a we've got a bug. But hopefully you recall before if we had like three shapes. I can't even demonstrate it now, but if we have like one in the middle, it would like flicker. I'd love to know what that. Oh my god, what have we done? What have we done, Daniel?
Ruined everything.
Okay, so we'll have to debug that. That's fine. But you'll recall that we had three shapes like lined up, and the one in the middle would flicker as the two on the sides would slowly move out because they were separating into each other. Um, and so the alternate to that is kind of actually does like what we're experiencing here, sort of, and that is, yeah. All right, that's really annoying. Um, so we'll come back to that.
Okay. I guess I have to look at it a bit more because I keep thinking that the only time we're like, other than in when we release a shape, we're resizing the pending separation buffer, but ultimately the pending separation is really only being used in do separation. So
Yeah,
I'll
yeah,
have
yeah.
to figure out why. Well, I was hoping that we could put the pending separation here, but you're saying
Oh,
no.
oh, that we can do actually. You're quite right.
Okay.
We could actually
So
do
just
that.
then we get rid of storage necessity on the main class because we can inline the
Exactly,
allocation.
exactly. So we could in fact get rid of that.
It's a working buffer, so no reason to move it or to keep it around.
So the only proviso I'd have on that, and I mean, like, this is a sort of weird far future thought. And what if we have like Um, like, I guess when you get to the size where this actually matters, if we have like, you know, a million shapes that we're trying to simulate, if we have a million shapes, like a whole lot of stuff has to change to deal with that. But if we had a million shapes, then we would probably run out of memory on the stack. Like the stack is limited to, I don't know what the default is these days. Is it 1 megabyte or 8 megabytes or something?
No idea.
So like this is maximum 20. Like this is per axis, and we're probably not going to have more than 20 axes per shape. But we could totally have a million shapes.
Right.
You know, particularly because that's user controlled. You could be like shape, 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 shape.
Right. We'd have to put a governor on that.
Exactly.
Or or start like culling them from the simulation at a certain point. Like if we were making that game where things get smaller and smaller, we'd probably just kill off so that the buffer stays a certain size.
Exactly. So
but
okay. In this case, we will crash when we run out of our 2 gigabytes of address space. That's a lot of shapes. Whereas if we stuck the allocation in to do separation, then we crash when we have, like, I don't know, a lot fewer shapes, put it that way. And so we'd rather crash later rather than earlier. But I guess at some point you do crash when you allocate too much. So that's the logic behind that.
Okay.
Any other questions? Sorry?
Yeah, no. I said I'm fair with keeping it the way it is.
Yep.
That's a good explanation. I'm good to go for today.
Excellent. All right. Thanks for watching, everybody. We'll see you next time.